All right, let's talk about these two. Number one, how do I approach this? Distribute. We're going to double distribute to this trinomial. So I'm going to get 6x cubed minus 2x squared plus 8x. And we're going to take this minus 5y and distribute that to each piece. So minus 15x squared plus 5xy minus 20y. Are there any like terms that I could combine?
No.
Nope.
Yeah. You forgot the 15x squared y.
Yes.
Oh, thank you. 15x squared y. Thank you. Forgot my y on there. Now, are there any like terms that can be combined? No.
Oh, that's it?
That's it.
Oh, I didn't do it wrong.
Other than maybe switching the minus 50, like move the minus 15x squared y right after the minus 2x squared so that it's in decreasing order, but I'm not going to get super picky about that. You've got all the correct terms. All the correct signs are with the correct terms. Everything that can be combined has been combined. We're good. You doing okay, Sage? All right. Number two, we need to factor this guy. What method makes sense as we are looking at it initially? Yes, sir. Factor by grouping. So I've got my first group and my second group. What could I take out of the first group? X cubed. What would I have remaining then? X squared minus 9. What can I take out of the second group? Positive 27, and that leaves me with x squared minus 9, which is a good thing because that means I know x squared minus 9 is a factor here. And then x cubed plus 27. Is that my final answer?
No.
Why not?
Because you have a perfect difference of perfect squares.
We have a difference of perfect squares, so that can factor further.
And the
A difference of cubes.
Yeah, whatever.
Yep.
Yeah.
We've got a sum of cubes then.
Yeah.
Yes. Which we're going to factor using soap. Let's do our difference of perfect squares first. How's that going to factor for me? X plus 3x minus 3. And then for my sum of cubes, I'm going to need to know the cubed root of each of these terms. Cubed root of x cubed is x. Cubed root of 27 is 3. I can't imagine for any reason why I would have you go above 7 or 8 on cubed roots. So if it's bigger than 125, you know it's probably a 6, 7, or 8. I'm not going to have you guys do cubed roots of things that are like, what's 11 cubed? I have no idea. On a test, on a quiz, on things that are timed, I'm not going to have you do stuff like that. We're looking at concept, not necessarily super difficult computation, but big ideas. So how will this guy factor? Give me my linear factor first. X plus 3, same sign in my linear factor. And then x squared minus 3x, opposite sign there, plus 9. Can I factor any more than that? No, your quadratic on a sum or difference of cubes will always be irreducible. All right. I wanted to do just a little bit more practice with rationalizing. We did practice rationalizing the denominator right at the end of class yesterday. I want to do 2 quick examples for rationalizing the numerator. And I want to make a comment about this, that as far as the numerator goes, we will only rationalize this with directions. Rationalizing the denominator is an always thing. You see radicals in the denominator, you do that. I don't care whether the direction said to or not. Unless you see these directions. If it says rationalize the numerator, then you rationalize the numerator, and you can't rationalize the denominator. If you have radicals on one side or the other in your fraction, you will only be able to rationalize one side of it. If you try to rationalize the denominator after you've done the numerator, you're just going to go back and forth and back and forth. So this will be the only time that we rationalize the numerator, is when it explicitly says to. In my numerator, I've got two radicals separated by what? Subtraction. When I have radicals, or even just one radical, and I've got pluses and minuses, what can I multiply by to make all the radicals cancel?
Conjugate.
Yes, we are going to multiply by the conjugate. So what will the conjugate for this be? Radical A plus radical B. Top and bottom. Why does it have to be the same top and bottom?
Because 1.
Yes, that fraction reduces to 1, so I'm multiplying by the equivalent of 1. After I double distribute and combine like terms, how will that numerator come out?
The radicals will cancel out.
Radicals will cancel out, so I'm going to have A and B. How do I know what sign to put in between them?
Keep the same.
I've got two signs. I've got a minus and a plus. It's always going to be a minus in between them. Always going to be a minus in between them when I multiply conjugate pairs. Down in my denominator, I am not going to distribute this. And I will show you why. But for right now, just follow along with me. Whenever I have a fraction, I don't care if it's a rational expression like this or something like 3/6. I always need to make sure what is true about my fraction before I call it done. Simplified, fully reduced. If I distributed that denominator, I'm going to miss how this reduces. One of those pieces in the denominator is jumping out at me. Sort of. Why is that factor right there catching my attention? It's a difference of perfect squares. A minus b and a plus b. Why is that of interest to me? It's going to cancel out with my numerator. So I'm going to go ahead and do that. I have a minus b in my numerator. Down in my denominator, I have a minus b, a plus b, and then radical a plus radical b. It's going to cancel out here, which means my final answer, fully simplified, is going to be what? 1 over a plus b, and then radical a plus radical b. I would not distribute that denominator back out. I almost never, I'm trying to think of a single example of when I distribute a denominator and I can't think of any. Even when I'm going after a common denominator, maybe if it's whole numbers, I'll multiply, simplify. But if it is any kind of expression like these guys, I leave them in their factored forms for two different reasons. One, when I look at it, I can tell for sure this is fully simplified now, that it's fully reduced. If I distribute that denominator earlier in the problem, I'm not going to see that it reduces. The other reason why I leave it like this is it's less places to make silly mistakes and lose points. If I leave it in its factored form, it's considered simplified. And if I start distributing things and combining like terms, there's a lot more places for silly mistakes to take place. So far, so good? Looking at that bottom one, you gross.
Yes.
But the same big idea is what we did up above, right? I've got a radical, a minus sign, and a radical. And I want the radicals to be gone in my numerator. So what can I do to get rid of the radicals in my numerator? Multiply by the conjugate, yes. So the conjugate of this is going to look exactly the same, but with a plus sign in between those two radicals instead of a minus. All right, so times radical 2 times x plus h plus 1 plus radical 2x plus 1 over the exact same thing. And I'm going to cheat by copying and pasting. You can double distribute this out, but one of the reasons why we've been talking about multiplying by conjugate pairs is I really want you guys to pick up the pattern that's going to happen so that we don't need to multiply those together. We know how it's going to come out. My first term is going to be what? 2 times x plus h plus 1
Minus 2x plus 1.
I'm going to write down something wrong, and I want you guys to tell me why it's wrong. Why is that incorrect?
We had to distribute the negative to one.
Yes, we are subtracting everything that was under that radical before. So I'm going to need parentheses around this guy so that I remember to distribute the subtraction to both of those pieces. Over, h was already down in my denominator. And then I have this horrible thing, 2x plus h plus 1 plus radical 2x plus 1. Can we clean up that numerator at all? Yep. Let's go ahead and distribute that. I'm going to have 2x plus 2h plus 1 minus 2x minus 1 all over this denominator. Oh, thank you. It should be 2x plus 2h. Thank you for catching that for me, Erlen. Will anything combine? Yep. Positive 1 and negative 1. Positive 2x and negative 2x. So I have just a 2h left in my numerator, but what else do you notice?
The h.
H's can cancel. Do that in green. So the only thing left in my numerator is what? Just a 2. No more h in my denominator, so I just have the conjugate of what used to be in my numerator. 2 times x plus h plus 1 under the first radical plus 2x plus 1 under the second radical. That would be my final answer. I would leave it just like that. Hopefully, on those questions on 1.4 where it's asking you to rationalize the numerator, rationalize the denominator, hopefully those are a little bit easier. That 1.4 homework is due when? Tonight. Please let me know if you guys have any questions or if you get stuck on anything. we're going to start in on 2.1 now. And at least for today, I feel like this is usually a bit of fresh air for students. We're going to talk about equations. What's the difference between equations, which we're digging into now, and expressions that we were just working with?
Equations have an answer, expressions usually don't.
Yes. So I heard equations have an equal sign. Expressions can be simplified but not solved. Equations can be solved. Equations have a final answer. There's certain things that I can do with equations that I can't do with expressions. Everybody knows this one from Algebra 1. If you do it to one side, do it to the other side. Equations, I can do that because I have two sides of an equal sign. The equal sign acts like the center of your scale. You can't do that with expressions because you only have one piece. So we're allowed to multiply by 1, or any fractions that reduce to 1, but we're kind of stuck there. With equations, if I multiply one side by 5, as long as I do the same to the other, my scales stay balanced. Some quick terminology. Equations, a statement of two quantities or expressions are equal. And then a solution or a root is some number b. I don't know what that number is, but I'm going to call it b for now. That makes a true statement when it's substituted in for x, or whatever variable we're solving for. And that is the answer that we find. So we should end up with a true statement on either side of the equal sign. Things like 3 equals 3, 0 equals 0, negative 12 equals negative 12 if we substitute it back in. Give you guys a minute to get that down, and then we will look at some examples. I'm going to put our first two examples up. Talk to me about where to start on part A. Distribute. I want to distribute that negative 3 so that I can get my x's to the same side. So I have 4x plus 5 equals negative 6x plus 12. Plus 6x on both sides to get my x's together on one side. Do I want to set this equal to 0? Minus 5 on both sides. When do I want to set things equal to 0? When I want to factor it. So when I have a quadratic is when I would want to set it equal to 0. This is not a quadratic. How do I know? Yep, highest power of x is 1. All right, so I've got it down to here. 10x equals 7. Divide both sides by 10. X equals 7/10. This is how I would prefer your answer, because we are a no calculator course, so leaving it in fraction form is usually going to be easiest anyway. This one does come out to a nice pretty decimal. 0.7, yes. I'm fine with either one of those. For the most part, tests and quizzes, taking it out to its decimal form is an extra couple of seconds that you don't need to spend time doing. Leave it as a fraction, it's still fully correct, and it's less work. Where should we start on B?
Square root.
Yeah, we need to square these binomials. We need to expand these pieces out. Talk to me about how a binomial expands. What is the pattern? Yep. First term squared. Plus or minus close. When I square a binomial, I'm going to have AB and then another AB from double distributing. So this is the one where we have the 2AB.
Miss Bull,
Yes.
couldn't you just do a square root on both sides and cancel them out?
No, because of the 5.
The 5 right there. If I didn't have the 5, absolutely. Yes. If we didn't have the 5, we could do that, but that 5 gums things up there, because then we'd have the square root of x plus 3 plus 5, or x plus 3 squared plus 5, and we'd have to take the square root of that entire side.
Okay.
Nice observation, though. I'm glad you pointed that out. All right. X plus 3 quantity squared. How will this expand? X squared plus 6x, because I need to double the product, plus what? Plus 9. And then I've got this plus 5 that was already here. Let's expand the other binomial, x minus 2 quantity squared. X squared. I heard minus 4x. Yes, it would be plus 4. We need to combine our like terms together, like these guys. I'm going to take this opportunity also, though, to get my x squareds to the same side, because they cancel each other out. So I'm not going to end up with anything that is quadratic in the end, since my quadratic terms canceled. So 6x plus 14 equals negative 4x plus 4. Get my x's to the same side. I'm going to add 4x to both sides. And because I don't have a lot of vertical space on the screen, I am going to subtract 14 from both sides at the same time. So I end up with 10x equals what? Negative 10. So x is negative 1. Awesome. Let's go look at another one. You guys okay if I put up the next two? Okay. Where should I start with C?
Multiplying the first two by
Multiply the first two binomials together. So we're going to double distribute here. Is there any distributing that I should do on the other side?
Yeah.
Yes. We're going to distribute x to everything.
No, just anything in the parentheses.
Anything inside the parentheses. So only to the x minus 6, just to these pieces. All right, so I'm going to have 2x squared minus 5x plus 6x minus 15 equals x squared minus 6x plus 1. I know I'm going to need to combine these two together. Let's get our x squareds to the same side. So it's going to cancel out over here. I have x squared plus x minus 15 equals negative 6x plus 1. Is this going to work out like the last problem? Want to move everything to one side. Why do I not just want to get the x's to one side and the constants to the other? Yes. Starts with a q. I see this x squared. We have a quadratic. And to solve a quadratic, we have to set it equal to 0. So I'm going to add 6x to both sides. And I'm going to subtract 1 from both sides. So I end up with x squared plus 7x minus 16 equals 0. All right, so let's factor this guy. I need two numbers that multiply to negative 16 and add to 7. Nothing. This is irreducible. Does that mean I'm done?
No, you have to use the quadratic formula.
Don't say that.
Do you actually?
Mm-hmm.
Yeah.
If the problem says to factor, I'd be done at this point, but the problem said to solve. This has solutions. I just can't find them easily by factoring. All right, so quadratic formula.
Negative b plus or minus the square root of b squared minus 4ac divided by 2a.
There we go.
God.
Negative b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. So what are we using for a, b, and c? A is 1. C is negative 16. B is 7. Just those numbers, that's all we're grabbing. Sometimes people will want to stick x's in there. We're solving for x. Just grab the values. All right. I'll show you. You'll be fine. X equals negative or opposite of b, and b is 7. Plus or minus the square root of b squared, so 7 squared, minus 4 times a times c, all over 2 times a. There we go. So I come in here to clean this up. I have negative 7 plus or minus. 7 squared is 49. Negative times a negative, I get a positive here. 4 times 1 times 16. 64, because that's the same as 4 cubed. All over 2. What's 49 plus 64?
I don't know.
113.
It's not fact.
113. Does that contain any perfect squares as factors?
I don't know.
I don't know.
Isn't it
Well-
prime because 13?
13 is prime. That doesn't necessarily mean, just like how 5 is prime, but that doesn't mean that a number that ends in 5 is prime. So let's walk through it real quick. Does 4 go into this? No. How could you know for sure? Like just at a glance.
Into 112.
Yeah, 4 is an even number. 2 goes into 4. 2 doesn't go into this. So there's no way it's divisible by any of my even squares. Does 9 go into this?
I don't know.
Let's check. It doesn't have that many fingers.
Hold on. 113 divided by 9. How many times does 9 go into 11?
1.
Once. Minus 9. 2. Bring down the 3. Does 9 go evenly into 23?
No.
Cool. So it doesn't work there.
This would be 1.
Do I need to try 16?
No.
Nope, none of the even ones. 25?
30,
Yes.
40.
Does 25 go into this?
Yes.
No.
Come on now.
Please, come on.
I don't need to try 6. Does 49 go into this?
I don't know.
49 is really close to what?
7.
48.
49 is really close to 50.
I thought you were what are you about?
Trying to talk about how we can do some of these things in our heads without a calculator, without having to divide a bunch of things off to the side.
You are not catching me doing stuff like that forever.
Let's talk about some mental math skills here.
If it goes off of my fingers, I'm not doing the problem.
You don't need to go off your fingers. 49 is close to 50, right?
Yeah.
What's 2 times 50?
100.
What's 3 times 50?
I don't know.
60.
Wait, 150.
Thank you. So when I'm working with a number that's really close to 49, if I multiply it by 2, I'm going to be really close to 100. If I multiply it by 3, I'm going to be really close to 150. Neither of those are going to hit 113. So I don't need to try it. Does 81 go into this?
No.
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 So it is irreducible. No numbers go into this.
1 goes into it.
1 does go into it, but reducing a radical by 1 doesn't help. Leave it like this. The only other way I would potentially ask you to write down your answer is to write it down as 2 separate solutions, one that has a plus sign in between and one that has a minus. This is fully simplified. This is as far as I could expect you to take it without a calculator.
Wait, you said to do it or the
That's the only other way.
Okay.
Like if you write it down like this on a test or a quiz, yes, you solved it. You gave me 2 answers. If the test or quiz has 2 blank lines with x equals, write 1 down with the plus and 1 down with the minus. All right. Let's do D. I like this one better. Except it's got what that we haven't really dealt with so far in solving? Fractions. But unlike simplifying, I can get rid of these fractions. Yep.
Multiply.
If I multiply by my denominators,
reciprocal.
I can make my denominators cancel. You could pick reciprocals. I wouldn't, just because if I multiply by the reciprocal of 3/4 by 4/3, it's going to get rid of that first fraction, but then it turns everything else into fractions. If I multiply by just the denominator, it will cancel. If I multiply every single piece here by 4, oh goodness. I would end up with 12 over 4x, which just reduces to what?
3.
3. We're having a case of the Mondays on a Tuesday. That's okay, I've been doing it too. So 3x plus 20 equals, did I get rid of this fraction?
No.
No. I would have 8/5 x minus 4. I want to get rid of all of my fractions. Times everybody by 5. Am I allowed to do this same trick without an equal sign there?
Yes, no, maybe.
No. Equal sign is why I'm allowed to do this. If you do it to one side, if I multiply one side by 5, I keep that equation balanced by also doing what? Multiplying the other side by 5, so it rebalances. If I don't have an equal sign there, I can't just multiply this side by whatever I want to, or else I've changed its weight. I can multiply by 1, but I can't multiply by 4 or by 5. If I have an equal sign, I can do that. I could have saved myself a step and multiplied by what at the beginning to get rid of both denominators? 5 and 4, which would be the equivalent of what? If I'd multiplied through by 20 at the beginning, I could have saved myself a step here. I'm going to subtract 8x from both sides to get my x's to the same side. And I'm going to subtract 100 from both sides. Hello, hello.
You're late.
7x equals negative 120. Let's finish this and we'll call it a day, guys. Last but not least, what are we doing?
Dividing by 7.
Divided by 7.
No, it doesn't reduce.
It does not reduce. 7 is prime and does not go into 120. And so I'd leave that as my final answer. We will finish up 2.1 after your quiz tomorrow. There is not a whole lot more to go. 2.1 homework is due on Thursday. 1.4 is due today.